but something that I have to say. Um, it's an absolute pleasure to introduce Mr. Surya Satyavolu for this talk. I am Siva Ratinam. I'm an associate professor in mechanical engineering at Texas A&M. I've been here for 10 years, and I work in autonomous vehicle technologies for people who may not know of me. Anyway, let me introduce the speaker now. So Mr. Surya Satyavolu is a founder and CTO of Sirab Technologies. Sirab Technologies is a US-based and India-based startup developing advanced technologies for safe and reliable automated road transportation. He has 20 plus years of engineering experience developing embedded systems and software for various products and technologies covering wireless and wireline communications, medical devices, and safety and security critical operating platforms for aerospace and defense. He has 3 patents, several pending filings for patents. He has a master's from Clemson University and bachelor's from Indian Institute of Technology, Madras in India. And he's going to give a presentation on high-speed electric automated road transport. And with that, I'll let you speak, Surya. Thank you.
Thank you, Siva. Thank you, Siva, Korok, and everybody at Mace Innovation Research Center for having me here. It's my pleasure to speak with you all about something that I'm passionate about. So today, let me start off the slideshow. So today I'm actually going to speak about high-speed electric automated road transport, like Siva mentioned, which is something that I'm very passionate about, and that's what my company is focused on about as well, like quite a bit, the company that I founded. And I'm going to speak about from all 3 angles, actually, like science, technology, and policy, because something like this cannot happen without all 3 kind of coming together. So, I mean, to kind of set the imagination, like, imagine doing SFO to LA within 3 hours by road, actually. So nobody's talking about roads so far, like everybody's thinking that you need a hyperloop or a bullet train to do that. But actually it is possible by road, because a lot of vehicles today can do speeds in excess of 120 miles an hour. And actually Tesla performance model can do 160 miles an hour. And roads are cheaper, definitely, compared to hyperloops or a bullet train infrastructure. But again, like, can we do that? Like, I mean, of course, like automation of the driving function is the key, as you can kind of imagine, because human skills are a limitation to kind of drive at that speeds consistently at scale. Again, like, of course, to talk about it, let's start with the science. Like, I mean, it's a nice vision, but is the science really there? Like, I mean, if we talk about the safety aspects, like, I mean, let's get back to something as simple as measuring something, whether it is hot or cold. Like, that's a common living room discussion, like where wife feels it is cold or vice versa, and you want to kind of bring in the thermometer and quote the degrees, like where the temperature is. Similarly with the sound, like, somebody feels it's louder and the other person feels it's not so loud, but there's a scientific way of measuring it, like as to how much the actual sound level is. But with safety today, like, I mean, we are kind of measuring safety more like cavemen, like, you have to do it to kind of figure out, I mean, put your hand in the fire pit to kind of measure the temperature. So measurable safety is kind of a prerequisite to kind of achieve that kind of speeds. So kind of measuring safety as a measurable physical quantity. Can we do that? Of course, to kind of quote Lord Kelvin, I mean, why do we want to measure it? We cannot improve it without measuring it. Like, I mean, otherwise we'll kind of keep jumping hoops instead of really making progress. So, but to do that, there is certain fundamental theory behind why we kind of trust a thermometer. Like, and of course, the laws of thermodynamics are trusted. Like, that when you have heat flowing from a hot object to a cold object is something that we all agree on rather than kind of dispute that. So there are certain fundamental things that have to kind of be agreed upon to kind of trust the measure, like, essentially. But safety, when we come down to safety, like safety assurance, it is not yet that well understood as to what safety means as such. Like, so that is something that I wish to tackle. Like, of course, like I'm also interested in kind of working with academia to kind of see if I can frame this any better. But I thought, like, these are fundamental laws that need to fall in place to kind of agree upon something as a safety measure. Again, like this is kind of based on certain aspects like measure theory and algebraic topology to kind of understand that finite topologies are needed to finite number of topologies are needed to kind of test something and things like that. But these are the basis on which we can kind of measure safety. So much for the science aspect. Like, of course, assuming that the science falls in place, there are certain, again, like that on the technical aspect, there are foundational building blocks, as I call it, like that need to be there. Like, I mean, of course, there are other aspects of the technology that needs to be there as well. But to achieve high speeds, we need something as simple as lane keeping. But are we there yet? Like, because today everybody says that you can keep in the lane, but reliability is the key. Like, I mean, if you want to kind of do it at high speeds, you need to do that with the reliability of a bullet train track, for instance. Like, similarly, like we need platooning to kind of achieve scale. It's not just one car you want to do it like, but you want to do it at scale. That means you need to kind of increase the lane throughputs. And actually, like if you can kind of do it wirelessly, there is clear advantages to doing it by road than by even fixed trains. Like, because you have a lot more elastic trains that can kind of form dynamically. But of course, you need that technology. Like platooning is being tried out today, but again, doing it at speed and with a high reliability is very critical, because these are safety critical functions as well as very performance sensitive. Like the overall system performance is very dependent on how well these functions perform. And of course, like you need the other paraphernalia, like as to how you kind of communicate with the infrastructure and how you communicate between the vehicles and other stuff. But these are basic functional building blocks, as I would call it. So that's something that we are working on at CIRAB as well, like actually. To kind of illustrate the concept, I will show you a small animation, like essentially. So this is this animation kind of shows you, how platooning can actually streamline the flow and kind of increase the capacities of the lane as well as kind of achieve higher speeds. So as many of you may be knowing what platooning is, but for those who are not, like the wirelessly coupled vehicles are wirelessly coupled and synchronously controlled, so that the gaps are maintained at fixed distance, like between the vehicles. And you can push a lot more vehicles, as you can see, within a same lane, like that kind of a architecture. Of course, going down to our architecture, how we do it. Like, we believe in a combination of inertial and non-inertial navigation for doing the lane keeping, based on radar plus IMU. This is a kind of a proven technique, like that's used in a lot of things, like from guided missiles to rockets even, like but here we kind of depend on radar as the key external sensor, and IMU as the inertial navigation unit. And we use reflectors along the wayside, like these are high RCS reflectors. I'll be showing them in the next slide. But also, like, we do platooning based on, again, radar plus wireless communications. So these are the corner cube reflectors that I'm talking about. Those who understand the radar probably know them quite well. Like, these are high RCS reflectors. We intend to place them on the wayside strategically, so that they can be detected by onboard radars to kind of provide you the current vehicle position as well as a preview of the path, so that you can actually drive the vehicle within the lane. And also, similarly, for platooning, we will be keeping them on the rear of the vehicle. So this is again, like, showing a small conceptual diagram, like as to how we do lane keeping. There's a radar reflector at the corner. That there are actually two reflectors on each pole, like essentially, like one for the squint and one for the left perpendicular radars, like essentially. And squint ones kind of provide you the preview, and the perpendicular ones kind of provide you the current position as well as the yaw angle, like for the vehicle, essentially. And again, similarly for platooning, we use wireless communications between the vehicle with certain hard real-time capabilities to kind of synchronously control the vehicle dynamics, as well as the radar front-facing radars plus reflectors on the rear of the vehicle, which are used like markers to kind of provide the kinematic measurements. So this is the kind of architecture that we are kind of developing at Syrup, and of course improving on the technology as well. So anybody interested, I will definitely love to talk about it as well, like in more detail. And this is like the conceptual diagram. Like we use a guidance, navigation, and control based approach, like, you know, for actually controlling the vehicle. But again, like using these external sensors, as we kind of mentioned, we develop the guidance algorithms for, you know, calculating the reference trajectory, and then kind of control for actually following the trajectory, you know, as closely as possible. So much for the technology aspect. Like, I mean, there's a lot to do, but many of us, like engineers, would, as we understand, as we gain experiences, you may have the best technology, but unless the policy and economics make sense, like you don't get a chance to actually deploy that, like, so, or deploy that successfully at least. So as far as policy and economics, we feel that, you know, there is a certain key benefit to actually privatizing the road operations. Like today, all the roads are kind of managed by the government, either the federal government or the state government. To kind of illustrate, like something as simple as Airbnb is kind of scaled up because, you know, it's private property and everybody wants to monetize their assets. Like, you know, if it's private property, improve efficiencies and utilization is kind of understood. Of course, like there is definitely a promise on actually privatizing the road, because it did happen. Like, you know, cellular phones happen today, mobile phones as we know it, because FCC started auctioning spectrum to, you know, private operators, or kind of broken up the monopoly of AT&T and auctioned the spectrum for personal communication systems. And that's how we started having the mobile phones and smartphones even today, and data rates started increasing exponentially, and more than just simple function of voice, like data kind of was invented, much like Airbnb invented renting out, I guess. So new infrastructure is needed, and that can be best accomplished through deregulation and privatized roads. We need to focus on land use efficiency, of course, like to kind of arrive at a scalable automation solution. One thing is, like, you know, spectral efficiency is very key for why phones work. Like, similarly, unless we focus on land use efficiency, we are not going to achieve the higher speeds and scalability that would be needed. So we intend to kind of work with the key stakeholders to kind of enable this kind of vision, essentially. Now, there are some things that the policy and economics people can kind of ponder about, like how do we convince the government about the benefits of privatization and electrification, like essentially, of road transport. We can lobby for legislation. Of course, legislation is what drove in the 90s deregulation in the telecom sector. And there are other benefits as well with the current debt levels and the deficit the government is running, which was quite high even before the COVID. And with the COVID, it is actually spiraling out of control, I guess. There needs to be a way to kind of manage the fiscal deficit much better. And that can be done through privatization of key infrastructure like roads, like essentially. So that is a key benefit for the government, as well as kind of creating a lot of jobs and, you know, improving the economy and providing the nonlinear effect. Like, and how do we privatize? Like, I mean, of course, like if we kind of draw the analogy again back to spectrum, like it is auctioned through an invented mechanism like simultaneous multi-round ascending auctions. Like, in fact, like a couple of the inventors got a recent Nobel Prize in economics as well, like Paul Milgram and Robert Wilson. So that is one thing to look at. And how about kind of auctioning them as a package? Like, actually, like when you auction spectrum together with the road resources along the highways, like, I mean, that may be a better way to kind of attract operators to actually automate the roads as well. Like, so we think, like, of course, like the regulation is what everybody is talking about in the autonomous vehicle space. But we think like regulation of safety is important, but deregulation is as important, because That's one of the key hurdles that a lot of the autonomous vehicles are facing, like with the kind of speeds nor the level of functionality is not competitive enough, like I would say, like with what current manual driven vehicles can do, like which are actually performing way below their capabilities, like I would say. So that is in a brief note, like as to what I wanted to talk about. Of course, I would like to also answer a few questions, as many of you may be having, and we can discuss more about what we are doing as well, like, and kind of take it from there. So with that,
okay, thanks, Surya. I have some questions, so I mean, I'll just I have some technical questions and maybe policy questions, and after that, I let others take over, and we can just have a conversation. So you were talking about this lane keeping and platooning technology, like. Do you know, so do you have a sense of where we are? I know that like all these cars these days, pretty much most of the, at least the higher end cars that you buy, all of them come with this lane keeping technology, right? And of course, every manufacturer has their own performance and all that. Like in terms of what you are talking about, right? Like how far are we, like in terms of reliability, or are we 5% off or 10% off, or where are we on that?
Yes, that's a very good question. Like, because that is something that most people have a question: is, are we already there? Like, but I mean, a lot of lane keeping today, the way it is done, they don't assume any kind of support from the infrastructure. But for a function like that, we need to look at it from both sides, like onboard technology as well as infrastructure. Just because today there are painted lane guides, like everybody is using camera-based, lane keeping, like essentially for perception and all that. But there are inherent limitations, like how what vision can do, like as a guidance sensor. Like, I mean, basically because of, if you can get down to the technical aspects, like there's a lot of entropy in there, like which kind of blurs the actual information that you need for doing this kind of a positioning of the vehicle. So those are aspects like that can be done only if everything falls in place. Like I said, like the science, technology, and policy. Like that means like infrastructure has to be allocated for automated vehicles, and of course the technology has to develop towards achieving higher performance, which is higher speeds and capacities of the lanes. Like so, but the technology today, the way it is, like it's not focused. Like I mean, it's just a convenience feature, like that anybody can use it at their own risk or expense, like essentially.
Yeah, that's true. I mean, if you want to drive, I mean, if you want to drive, even at, I would say, forget about even 120 miles per hour, even if it's 75 miles per hour, reliably, if you want to drive over, stretch of a road for an hour or something, I think you need some support from the infrastructure. I'm not sure how you can do it purely based on onboard stuff, and right now,
sure, like, and what do you trust? Like, I mean, again, like, who do you trust? Like, I mean, that's why I'm kind of getting down to safety measurement,
yeah.
like, essentially, and you can take anybody's word for it, like, but you need a way of measuring, like, and kind of feeling comfortable. Yes, I can depend on this kind
So
of.
have you looked into this? There is this safety model that Intel has, right? Like, do you have any opinion on that?
Yes, I attended one of the initial, invites as well. Like the number is there, like something like. But I did kind of attend some of those meetings, like as well. Like again, like they are focused on trying to figure out like what the trajectory are from a bunch of uncountable infinite set, like essentially. So today, like unless it is guided transport, like I mean, essentially you run into the uncountable set problem, like which how much ever compute power you have, like there is no way to kind of arrive at anything conclusive, like in terms of kind of arriving at a safety measure, like essentially.
Yeah, like I mean, people have some models, but there is no consensus, of course. And since Intel got into the game first, they have some model, and we'll see how that goes. One thing. I mean, since I've been working with vision, what I've realized is there is, irrespective of how well it works, there's a lot of uncertainty with vision, and especially when you have challenging weather conditions. And that's the reason why I think radar-based technology is kind of very useful. Now, you were talking about these radars that you have made, or your company is making. How many do we need per mile of the road? I mean, do you have a sense of the relationship between reliability and the number of radars you need, and how costly are they going to be?
Actually, like we are currently working with off-the-shelf hardware, like though we kind of
Oh,
optimize algorithms, and I mean in terms of the number, like again, like you kind of rightly pointed out, like we need to have a reliability target, like essentially, like if you can kind of achieve it with one radar, there's no reason to kind of go with two, like for instance, as a redundancy, like because I mean after all, like a lot of things like airplane wings are only a couple, like I mean if something breaks, like the airplane would crash, but you still trust it. Like similarly with wheels, like of a bullet train, I guess. Like so it is possible to achieve high reliability even with one, is in my opinion true. That is as far as the redundancy goes. But of course, like for lane keeping, we need 4 radars, one on each side to kind of provide you the current vehicle position, and 2 on squint looking ones to
mhm.
kind of provide you a preview of the path. Like and similarly for the platooning, like we need 2 front facing ones. Like so that is the number of radars we need on board the vehicle. And in terms of redundancy, of course, we go for a fail-safe design, like essentially. So if something fails, you should be able to put the vehicle in a fail-safe state without actually causing a safety issue. Like so, that
Yeah.
is our design philosophy, and that can be done like with because of the way methodology itself, like essentially. So
The reflectors are relatively cheap, is it? Right? The reflectors are cheap, right?
yes, yes, of course. Like you can go for design like that is robust and reliable enough for various environments,
So, like
and
in
kind
terms
of
of
protect from occlusion and other things.
yeah, the pole kind of reflector that you had, how many do you think we would need, or is it? I mean, like, do you have a sense of?
Yeah, again, corresponding to each radar on board, we need a reflector, like essentially corresponding reflector that looks in the same angle, like on the other
Okay,
side, like it has to present the broadside aspect, like so. And on each pole, you can mount 2, like one in the perpendicular looking and one in the squint looking mode, like essentially.
okay, okay. And you are doing all the computations. You're doing computations on board. Like, are you thinking of smart chip or something that does all this computation, um, where are you doing all the work in terms of processing the data?
Yes, we are currently working with certain off-the-shelf, like Intel boards and other things like multi-core SoCs, but the core algorithms that we use are not the AI algorithms. For instance, like when we use more of guidance computations and model predictive control for control algorithms. So it needs to be optimized for this. We are also looking at developing our own hardware architectures. Like we have an onboard FPGA for many of these SoCs, and on which we can kind of see if we can optimize or accelerate some of the algorithms. But we are in still early stages. Like I mean, we are still we are looking to raise money, like to kind of fund that kind of activity. But currently
Mhm.
we are that's a
Uh,
possibility.
I see. Yeah. You were talking. I see that you have worked on the communication side of aspects earlier in your career, and I think the auction mechanisms are definitely it's already implemented on the communication side. In terms of road transportation, like, are you aware of any other places where this auction mechanism has worked? I know that people have been talking about these auction mechanisms for intersections, like that's been some, I mean, but it's more on the research side. In terms of practical use, I mean, has there been any work or any implementation in Europe or other countries, or?
Yeah, it has to be done holistically. Otherwise, like the auctions would not really work well. Though there is certain privatization of roads in Europe, like I believe in Norway or Finland, like they are trying to privatize roads. Particularly toll collection and other things are kind of privatized in many parts of US as well. Like, but unless we do it with a vision to kind of automate things or kind of provide that technology push. It won't be effective enough. Like, I mean, a lot of the spectrum auctions kind of became effective because there was clear focus on personal communication systems, like at that point of time. So that kind of technology push also has to be there, like to when you auction these things. So
yeah, yeah. I know that like Northern Europe has, I mean, of course, everyone is developing platooning technology, but there seems to be a higher push even amongst countries to test this technology, or amongst companies. There seem to be more greater coordination in Europe than here. But anyway, so just last question, and I know that I've been asking a lot of questions, so I'll let other people ask. You mentioned about land use efficiency, and can you just elaborate a bit more on that? Like, what do you mean by that? Um, is it just a side of the roads that you're talking about that you want to use efficiently, or is it the poles? Like,
it's actually the lane itself. Like, I mean, a lane is a resource, like it's a scarce and shared resource. Like, I mean, in a way, like a lot of the cellular technology is very focused on optimizing spectrum because it's auctioned at competitive prices. Like, it's people realize that it's a scarce and shared resource, and then you want to kind of optimize for multi-user capacities and increase data rates and everything like that. So, but today the roads are kind of a public resource that is not really optimized for people's use, like in my opinion. Like, when like a lot of traffic congestion can be traced down to that. Like, I mean, but if you automate and increase the throughput for multiple users, you have better land use efficiency. Like, instead of using 4 lanes, to kind of give you a simple example, 4 lanes moving at 15 miles an hour has the same throughput as 1 lane moving at 60 miles an hour with the same inter-vehicle distance, like on an average. Like, so you save on both the land and time. Like, I mean, so you optimize on both space and time by doing automation right, like essentially. So that is the kind of land use efficiency that I was talking about.
oh yeah, okay, yeah, okay, good, okay, thanks. Okay, you guys, I'm just opening up. If you have any questions, please ask Mr. Surya. I'm just getting some questions in the chat window, but can you? Yeah, you can just directly ask and through. Just unmute yourself and ask.
I think there are some questions in the chat.
Yeah. Okay, so Abhishek, do you want to ask the question? If you can unmute, otherwise I can read it. Oh, I see. Okay, that's okay. So this is a question from Abhishek. So since you talked about high-speed platooning, have you looked at cases where a vehicle may have to platoon for cases like exiting a highway, or how it affects the platoon? Like, I think the entry and the exit points of a highway, right? And how that affects the platoon or the organization of a platoon. Like, are you thinking about that, or?
Definitely. Like, I mean, again, like this is something that we have in mind. Like, again, I only refer to the fundamental building blocks so far. Like, this is as fundamental, but I mean, that kind of makes sense after we have platooning and lane keeping working, I guess. But yes, ingress and egress is a very important thing, and we should be able to do that dynamically. Like, where vehicles can kind of detach from each other while at speed, and kind of allow the vehicle to kind of leave the platoon and kind of rejoin back. So that's the kind of functionality that we are envisioning. And also, like, it'll be quite structured, like, because we use this infrastructure support, it'll be exiting at predetermined points. Like, so the topology of the road itself is predetermined. Like, I mean, it's not like dynamically kind of today the possible trajectories are kind of humongous, like actually uncountable. But we are looking at structured automation. So, but like you rightly pointed out, like it should be possible to kind of exit and enter the platoon at speed.
Yeah. Like, have you thought, how much are the delays actually in place? Like, I mean, are you worried about the communication delays between the vehicles?
It's more about bounded delay than the actual latency. Like, it has to be bounded enough to provide you the guarantees on the jitter. So because it's periodic control, right? So if you're kind of optimizing it for control communications, you want to have a time scale on which it works. So it has to have bounded delays, so that you can kind of accommodate the necessary communications within that time period.
Okay. Thanks. Any other questions? Korok, if you want, you can ask any.
Yeah, sure. I have some questions. Great.
Yeah.
Okay, thank you, Surya. Well, this is my only technical question. I actually asked you over email, but I wanted to get your opinion for the group, which is the debate on LiDAR versus radar. I know there's some disagreement both among the public and even when I sent that email to some people. Just what are your opinions about LiDAR technology?
Before we get down to that, is it a worthy debate? It makes sense if we decide on the functionality first, because you have to, before we can kind of compare apples, apples and oranges, at least they're same fruit, but if you talk about LiDAR, it is kind of trying to sense environment all around itself and kind of trying to figure out a path, but radar, the way we are using it is for a specific function, predetermined function, where you want to kind of keep within the lane, where LiDAR would do a lot of different things, but it has to do what is necessary with the required reliability. And that is where radar has clear advantages compared to a LiDAR.
Okay. Surya, you began your talk with this statement about high-speed transportation, 120 plus miles per hour. I actually had not heard about that as a goal. I traditionally, when I followed this literature, it was about reducing the number of fatalities. 40,000 Americans per year were killed on highways. What is your? I guess tell me why did you pick that metric of high-speed transportation? And do you think that's because I would think that would, all else equal, that would be more dangerous to be driving at those speeds, and so then it's not clear that you'd be able to achieve both.
It's a bit ironic, but speed can achieve safety, I guess, because after all, the Shinkansen is probably the safest benchmark, I would say, the Japanese bullet trains, which run at quite high speeds, So in that sense, speed has to kind of provide the economic impetus ultimately, but again, safety is achieved in terms of scale and land use efficiency and other things that kind of come into picture. And automation, if done right, can achieve safety. But to do automation right, you need the other pieces to also fall in place. So that is. That can be, and speed is an important factor, to kind of achieve land use efficiency. I kind of mentioned, with higher speed, you can make better use of the land resources as we go along. And that's one of the reasons why data rates increase, or we look for high speed communications. So speed is a very important thing to kind of optimize on both space and time.
Yeah, so I guess I'm glad you said that, because I think it tells you that there's a lot, the inefficiency is the travel time that's wasted driving from Houston to Austin. That should take ideally half an hour rather than 3 hours.
Yes, and a lot of cars are actually underutilized today. Because the capability is there in terms of achieving the speeds. So.
Yeah. But this seems more like a vision for intercity transportation rather than intracity transportation, urban transportation, where there's also a lot of wasted times, like sitting in traffic in Houston. To what extent does your technology apply to that use case?
Actually, the one thing that we need to kind of understand is a lot of urban traffic congestion is actually on highways and freeways. So in a way, like if you increase the throughput of or kind of get the architecture right and can kind of increase the throughput on a lane, there's nothing stopping you from kind of doing it in an urban scenario as well. Like because I mean, most freeways in California, at least, like if you go into the Bay Area, all the freeways which are supposed to be intercity highways, for instance, the interstates and everything is kind of congested in the urban scenario. So they can also benefit from actually automation.
Okay. Let me now talk about your economics side of this on the auction. So let me think of the spectrum as one example. And so what I know about the spectrum auction is the users per se are not really bidding in the auction. There's these wireless carriers like Sprint and T-Mobile that are the bidders in this auction. But when I try to move that analogy over to road pricing, are you imagining that the drivers through their computers and their machines would be bidding, or would there be infrastructure companies that would play the role of the wireless carriers, or maybe the wireless carriers themselves that would be the ones doing the bidding?
Actually, you'll be surprised when the auctions were started, like social justice was a key goal, like actually like kind of enable minority businesses and women-owned businesses to kind of participate and kind of bid on that. Of course, like over a period of time, things combined and companies became larger. A lot of churn happened in the communication sector. And today, again, like we have two big large entities, like I guess like a Verizon, AT&T, and maybe a few others like that kind of competing on that front. But ultimately, like we want to create a marketplace at all levels. Like, of course, like we want the bandwidth to be auctioned down, where people can kind of reserve a slot, for instance, a reservation-based mechanism to kind of, do a trip from certain time to certain time, where it can be sold like airline tickets, for instance. But that can really happen if there is a supply side push, right? Like, the supply side is currently the one where we have limitations today, like, and the supply side can be enabled like by actually enabling infrastructure development that can be best accomplished through businesses rather than the consumers directly.
And so that infrastructure development is really going to be that key step, because it seems to me just that the wireless example in the airwaves and cell phones, that market seems a little bit more mature than even road pricing, where there's just a big disconnect between the driver in this case and the government. There really isn't even a good market yet for those infrastructure operators. They have to really that market has to develop, right? Yeah.
Yes. Today, like, roads are kind of managed by the government in total, like, right? Like, pretty much it's a federal government, whether if it's interstates and if not like state highways. Those need to be privatized, like, where private players can actually take over the operations. And that's where the new operators can have a place to play, essentially.
Yeah, and I think when you mean privatization of the usage, not the privatization of ownership. Like, you're not expecting the actual the government to give up the land itself, just with the usage of the land.
Yeah, it's again, like it can be a lease, a long-term lease, for instance. Like, if you're concerned about the property rights issues, like, that can be accommodated where the government ultimately holds the ownership of the land itself, but the operator has a long-term right to use, like, essentially.
Right, right. And from your perspective in industry, what is is there general agreement that privatization is the path forward, or do you feel like even among the companies, your competitors and your suppliers, that they don't even think that?
Currently, like, there's been a lot of distraction from autonomous vehicles, and everybody has been kind of discounting the land, like, or kind of not even thinking about the roads that with the required depth, at least. Like, everybody's thinking just that you can kind of place the painted lane guides and the government will lay those painted lane guides and that it will all work hunky-dory. But we think like infrastructure is a key component and that needs to be rethought out. Like, and yeah, we are seeing definitely some people kind of talk about it, but not enough to kind of make it happen right away, maybe. But I may be wrong. Like, I mean, if and now is a good time, like, because new election, new president. If it can be pushed, like, there are a lot of things that can kind of fall in place, including social justice goals to infrastructure development and cutting the deficit levels and debt levels. But somebody has to make that push, and that's why, like, we are very keen on that as to how best to kind of accomplish that.
So you don't believe software itself could fully solve this problem, even as AI gets better? It'll never close the gap to get to the safety standards that we want.
Yes, I mean, of course, like, that is for sure.
Yeah.
Yes. I mean, that is, again, like, there's some clear technical limitations, like where we kind of analyzed it at required depth to kind of understand that, you know, it's not something that can be done by a digital computer, for instance, to kind of provide the safety assurance. I mean, of course, it kind of gets down to a lot of quite theoretical aspects, like, you know, measure theory to algebraic topology and other aspects like ergodic theory and things like that. But I mean, you can kind of understand that there is certain limitations, like as to why we cannot accomplish any kind of measurable safety assurance with artificial intelligence methods or onboard technology methods.
So I guess if that's the case, let me play devil's advocate. Why is the entire industry investing on vehicle-only technology? I mean, it doesn't, like Tesla, all the big players are only assuming that the roads will remain as they are, and that they're just developing. It seems like that we're just marking down the wrong path. They should completely reconsider this. But the companies are, why is that?
There is not enough incentive to kind of tackle the big elephant, I guess. Like, I mean, the government is a big elephant, but a lot of these are for-profit organizations that kind of work on vested interests. Like, so the innovation, as much as everybody wants it, like, I mean, it needs to be incentivized to kind of make it happen. Like, and that's where, like, startups play a big role. You know, there is a reason why Bell Labs couldn't do cell phones, like, as well as Qualcomm finally did it, like, essentially. So there is a scope for startups to kind of rethink the business models and kind of incentivize the new world, like, essentially the new innovation that kind of comes into place to solve the core problems created by the incumbents, actually, in a way, like, you know, because the existing system was created by the government, the big elephant, and the other top dogs, I guess.
So I guess so startups like you, I guess, will have to make the bet on an infrastructure technology rather than on just simple onboard vehicle technology.
It's a combination, actually. Like, I mean, the infrastructure is something that people don't think about that much. Like, but, you know, even for something as simple as a mobile phone, there's a base station at the other end. Like, so you have to think about both pieces, like, end to end, to kind of make it work. And it's IP, and the functionality is as important as the actual product itself. Like,
can you tell us a little bit on the infrastructure side? Are there startups on that side of the industry that are developing this technology?
There are some people who are looking at pavement markers, for instance. Like, there's some small startups. There's a roadside communications unit that people have been kind of focused on as far as DSRC goes. But nobody really has been thinking about it as a guidance system the way we have been thinking about it, at least. There have been some patents, I guess, like way long ago, like especially when PAT guys were working on this kind of a problem. I believe Shiva probably also worked on some of that at PAT, like, if I remember his bio. There was some platooning demos that happened in the 90s, but then at that time, like, again, like, they didn't have enough muscle to move the big elephant, like the government, to actually get to a point where they could deploy it at scale. Today, like, I think, like, it's right time, like, essentially, like, because it helps everybody, including the government and the people, like, essentially, like, by actually going the automation route, like, instead of spending enormous amount of taxpayer money on you know, the boondoggle, like a bullet train or even hyperloops and other things, we can actually automate the roads to achieve a lot of different important objectives.
Yeah, no, I agree with that. It just seems like this is a hard nut to crack, because you would need some consensus in the industry that this is the path forward. and the government is just going to observe companies like Tesla continuing to refine their own onboard vehicle technology and think, well, why do I have to do anything, right? So just thinking through a little bit of the politics of this, how could this work? I mean, how would, because it would require some coordination of some kind, or maybe a body outside of the industry, either a trade association or a university consortium. Is any of that happening?
I mean, that is again, like the consortium is something that we have to champion, I guess. But I mean, you'll be surprised once a marketplace is created, there's a ton of money in the private sector and people also risk-taking ability. I mean, if you come out with a legislation that says like we're going to auction the roads for automated vehicles, I'm pretty sure like there will be a lot of private players who will jump in, like, you know, with big money bags, like essentially to kind of bid on it. But that is something that the government also has to think about and kind of make it work. Like, of course, we can try to champion because we have vested interests ourselves, like on the technology front. But the forming the consortium can happen once the government kind of comes up with a legislation or something that says like, you know, we are authorizing this particular government entity to kind of handle privatization of the roads or things like that.
Shiva, do you want to say anything about what we're doing at A&M on?
Yeah. Just to follow up on that last question and what Surya answered, I think we need, of course, we are talking about governments in general, but if you just take US, the way things work in Texas is very different from how things work in California, right? So I think there has to be at least one place somewhere in US where if I don't know, this consortium, if some local law can be passed somewhere where this proof of concept technology has to be tested on a reasonably large section of the road. All the work that has been done in terms of using infrastructure and all that have all been in universities or in research facilities, but I think there has to be some kind of a push towards doing it over some section of the road that public uses, right? And there has to be some local legislation, and I think if people can see the benefits, I think once they see the benefits, as Surya rightly pointed out, I think I'm sure things will happen. I don't think other states are really. I think all states will jump in, but someone has to do the push.
For instance, our company won a letter of intent from a large international airport to do an airport people mover, for instance, based on buses instrumented with our kind of a technology. If you know what an airport people mover is, a terminal to terminal landside train kind of a thing.
Yeah.
We could show a lot of capital efficiency and a lot of cost benefits to actually doing it by road. For instance, that's one thing like that I wanted to mention. And also bus rapid transit in many places is not working at the required, operating efficiency to kind of generate profits. A lot of places it's lossy. There's no reason why it has to be. And automation will help, like for instance, like a bus rapid transit system or bus corridor to actually increase the usage and utilization such that, and also service levels with automation. And there are bus lanes that are being laid out. I mean, they're being taken out like in a number of places, but that's where, like, if government managed roads, that's the big problem, like where people can take out a learn without any clear roadmap as to how they will improve the throughput. For instance, what if that lanes are kind of today being used by cars, and you take out a lane and kind of say you allocate it for buses, but then the number of throughput measured in either vehicles per minute or whether it be people per minute or whichever metric, there needs to be a way to kind of provide the increased throughput as we go along, at least a roadmap to kind of leapfrog and kind of provide you the necessary throughput benefits, like essentially. So that's where, like, if it's a private operator, he'll have an incentive to absorb this kind of a technology to increase the speeds and capacities, like essentially.
Yeah, I agree. I think even I think based on, I mean, I've been working on this for quite some time now, and I really think some additional inputs from the road infrastructure would greatly help towards this. And as you pointed out, there are a lot of questions from the from the politics side, at least. So at A&M here, we are working on several projects related with autonomous vehicles over the years. Platooning onboard high-speed lane following and platooning is something that we have been working on. In fact, Abhishek and Kenny were among my students who were involved in that. And we are also working on a project where we are trying to characterize the quality of lane markings with the onboard autonomous technologies people use. So so you'll be amazed as to how the lane markings that people have, right? I mean, the quality of the lane markings actually impact the vision software and all that. So that's something that the relationship is something that we're working on. There are also other practical aspects that other faculty members are working on, which is including, deploying some of these vehicles, in the city, right? Showing how autonomous vehicles can work in College Station and other places, and not in just ground transportation. In other areas, in aerial transportation, there has been a lot of work. Actually, in aerial transportation, you can notice that yes, there are some privacy issues and all that, but there has been tremendous progress there simply because the regulations are lesser compared to the ground transportation. So in terms of cutting edge technology in every topic, there has been a lot of work at A&M from the aerial side. Yeah, so we have actually people from mechanical, aerospace, and electrical engineering working on some aspects of this. We also have faculty members from architecture, the College of Architecture. They work on, in fact, there is a institute that is trying to bring these autonomous vehicle technologies to rural population. So there is a small town in Nolan in Texas, which is near to Austin, called Nolanville, where the city is very interested in bringing this technology. So they are completely working with some of the faculty members in the College of Architecture to make it happen. So in terms of whatever we want to test, in fact, we are trying to test out some of these road-based autonomous driving technologies and other things in that city, because we have complete access to all the roads there, and the mayor there, and all the community folks are very interested in working with us. So that is also something that's happening. So anyway, this is the kind of summary that's been happening at A&M.
Sure. That's very promising. And one aspect that I thought I would mention is there's a lot of research going on in autonomous vehicle space, but I think objectives have to be also researched and kind of well laid out. Like when we talk with whether it's city or other people, essentially in performance metrics, is the city really focused on land use efficiency, increasing speeds, increasing service quality? There are a lot of other aspects that also need to be negotiated when we bring in a technology, especially because they impact the kind of technology development that kind of happens. Because conceptually, everybody gets it. I guess, everybody knows that we want self-driving, and we want higher speeds as well. That's the reason a lot of automakers are also increasing speeds and other things. But the objectives, I think the academia also has to get involved in kind of defining this objectives and metrics to kind of assess how well we've been doing so far.
Yeah,
that's very key as well.
Yeah, for sure. And actually, one aspect I forgot to mention is This is something we are really working, we are trying to work on it at least, is that most of the technologies is focused towards urban transportation. It's about highway transportation and intercity or intracity transportation, right? But a lot of population actually live in rural areas. And if you look at cities like Nolanville, they're kind of near to Austin. They're not that far away from Austin, but they don't even have a bus service. They don't have. There are hundreds of thousands. I would say millions. I would say like a significant part of the country lives in the rural side, and there's not much transportation there and all that. And actually, the local people there. In fact, the reason why we are even interested, we are even working with them is because there is tremendous interest there for people to provide some transportation. It doesn't have to be even high speed. And they're willing to make it work. They don't even have buses, and you're looking at a lot of people, a lot of veterans, a lot of disabled people who need transportation, and so that's basically the target area that we are looking at. It's basically a partnership started from the College of Architecture. So the rural side also is something that I think is important. But of course, there is always, for private players to come in, there's always this cost benefit analysis. But I think, there are some advantages the rural side poses in terms of there is safety is not that, safety is of course important everywhere, but it's easier to achieve, I think, in places where there is not much traffic, where the local communities are willing to bend over to actually to accommodate these new technologies. And if you can, I guess, make one town work, let's say, then the at least the hypothesis is that, given that we have hundreds of towns in US, things will work. But
Sure, that's a very important point. Again, of course, like higher speeds is a larger vision. Again, like that's why I said, like, so foundation is what we are kind of addressing right now. And rural is a very important aspect, because you can, like you said, like, you can start off without too many constraints, but at the same time, like, we can come up with a new architecture that's scalable enough, kind of address, multiple settings as we go along. Like, instead of just focusing on one niche, like, and that is possible in a rural setting as to begin with.
The radars that you had, that you were showing will work in a rural setting, I think, because they don't even have lane markings. Like the towns that we travel in, they don't have lane markings. So I think this radar, the reflector-based technology will work better, and it's cheaper and all that, and it's a bit more reliable. So I think from that point of view also it works. And if you look at the recent all these awards that the federal governments, there is a push also from the federal government to help you work in the rural side.
That's very interesting. Like, definitely I would want to kind of discuss on that front offline, like, to kind of understand how we can kind of work together.
Sure. Okay. Thank you, Surya. Thank you so much. I know that we are already, a couple of minutes past the noon mark, but thank you so much, and thank you for everyone for joining and asking questions. Yeah, we'll be in touch, Surya.
Sure. Thank you. Thanks for your time, and it's my pleasure.
Yeah. Thank you. Thank you, everyone.